What if I told you the moon isn't a destination, it's a gatekeeper? Right now, while you're watching this, there's a race happening in space that will determine who controls humanity's future beyond Earth. And the country winning isn't the one you think. China just brought back rocks from a place no human has ever touched. Those rocks revealed the moon has been hiding something for 4 billion years. Something that changes everything. Here's the part that should terrify you. China isn't exploring anymore. They're building machines that can 3D print structures from moon dust. Robots designed to mine water from craters that haven't seen sunlight since dinosaurs walked Earth. While everyone assumed this was about flags and national pride, China quietly figured out something far more valuable. The moon isn't a destination, it's the key to everything beyond it. And whoever controls the infrastructure there doesn't just win a space race. They control access to the entire solar system. The illusion we believed. For decades, we acted like the moon was finished business. Humans visited, soil samples came back, mission accomplished, chapter closed. But here's what nobody tells you. During the entire Apollo program spanning 6 landing missions, astronauts explored roughly 25 kilometers of lunar terrain total. That's all. Every single landing happened on the near side, close to the equator on flat ground chosen specifically because it wouldn't kill anyone, not because it offered the best science. And for 50 years, almost everything we claim to know about the moon came from that tiny cherry-picked area. Meanwhile, massive regions stayed completely untouched, the far side permanently hidden from Earth's view. The South Pole, where light and darkness create conditions found nowhere else. The moon's ancient scars, impact craters so deep they ripped through outer crust and exposed material older than most rocks on Earth. So when scientists said they understood the moon, what they actually meant was this. They understood the safe parts, the parts convenient enough to reach without dying. And that's where China's approach becomes interesting. Arriving late doesn't mean arriving unprepared. The strategy nobody saw. When people compare China's moon program to Apollo, the word late comes up a lot. The United States put boots on lunar surface in 1969. China didn't land anything until decades later. But that framing misses the entire point. Apollo wasn't built for the long haul. It was built to win a single moment. The objective was clear: land humans, prove it's possible, bring them back alive. Modern lunar programs have completely different goals. Because arriving is relatively simple, staying is what breaks you. And China structured their entire program around that truth from day one. Instead of racing astronauts to the surface for cameras and headlines, they moved in careful stages. Orbiters first, mapping the moon in detail no Apollo mission ever achieved. Then landers proving controlled descent worked. Then rovers, machines that could move, survive temperature swings, and function for months. Then sample return missions bringing actual material back to labs on Earth instead of just pretty photos. And only after all that infrastructure testing, preparation for crewed missions. No pressure to meet arbitrary deadlines. No need to make it look heroic for television. Every mission could fail quietly, teach lessons publicly, and improve what came next. By the time China seriously planned to send people, they already understood something Apollo never had the luxury to figure out. What actually stops you from living on the moon long term? The far side reveals everything. For half a century, one entire hemisphere of the moon was basically invisible to science. The far side never rotates toward Earth. No direct radio contact. No Apollo landings, no samples. That reality ended in January 2019. China's Chang'e 4 mission became the first spacecraft in human history to touch down on the lunar far side. And the landing site wasn't random. They aimed for the South Pole-Aitken Basin, the biggest, deepest, oldest impact crater the moon has. This wasn't a stunt. It was geology. That basin formed when something massive slammed into the moon with enough force to blast through the crust entirely, exposing layers from deep underground, possibly even mantle material. Then Chang'e 6 arrived in 2024. This time, China didn't just land and look around. They brought back nearly 2 kilograms of material from the far side. The first samples of this type ever returned to Earth. And what those rocks revealed didn't match predictions. The far side wasn't just visually different. It had a completely different history. The composition, texture, and age of volcanic material didn't align with models. According to long-standing lunar theories, the moon, especially the far side, should have cooled fast and solidified early. But the samples contradicted that. The moon stayed hot far longer than expected. That implies internal activity continued deeper into lunar history than anyone thought. That matters enormously, because a moon that cooled slowly is a moon that might still contain energy reserves, volatile materials, and structural complexity below the surface. Exactly the things that determine whether long-term human presence is actually feasible. At a certain point, studying the moon stops being about curiosity and starts being about survival. Resources change everything. Understanding lunar geology is useful, but staying anywhere in space ultimately comes down to resources. China's missions uncovered two discoveries that quietly transformed the entire conversation. The first was water, not underground lakes or flowing rivers. Real water molecules chemically locked inside lunar soil minerals. That discovery matters, because water is never just water in space. It's oxygen for breathing, hydrogen for rocket fuel, radiation shielding against solar particles. The difference between hauling every single thing from Earth versus making what you need locally. The second discovery was helium-3, a rare isotope almost non-existent on Earth, but sprinkled across the moon's surface by billions of years of solar wind exposure. Helium-3 doesn't power anything right now. If fusion reactors ever become practical technology, it represents clean, incredibly energy-dense fuel with massive long-term potential. Just 40 grams of helium-3 could generate the same amount of energy as 5,000 tons of coal. And estimates suggest the moon may contain over 1 million tons of this element. But here's the critical detail. China isn't mining helium-3 today. They're not extracting water at industrial scale. They're doing something far more strategic. They're mapping exactly where these resources exist, how accessible they actually are, what it would require to use them without constant Earth resupply. Because you don't construct permanent bases where resources are theoretical. Build them where survival can eventually become routine. Once resources entered the picture, the moon's geography suddenly mattered in ways it never had before. South Pole bottleneck. Nearly every serious lunar mission planned today targets the same region, lunar South Pole. This isn't coincidence or copying. It's physics. Near the poles, sunlight behaves completely differently. Instead of rising and setting normally, the sun barely skims the horizon, leaving certain elevated crater rims bathed in nearly continuous sunlight. That sunlight equals power, constant, reliable solar energy. Just meters away, deep craters remain permanently shadowed. One of the coldest locations in the entire solar system where water ice can survive for billions of years undisturbed. Power and resources side by side. That's why China's missions converge there. It's also why NASA's Artemis program does too. This isn't one country imitating another. Physics forcing everyone toward identical conclusions. You remove atmosphere, weather patterns, and oceans, the moon becomes a landscape of narrow advantages. Edges that see sunlight, craters that trap ice, zones where energy production and resource access overlap. These aren't tourist destinations, they're choke points. And whoever maps and understands them first doesn't just visit the moon. They determine how everyone else will operate there for decades to come, which is exactly what China's next missions are designed to do. The real reason. Strip away the flags, the media coverage, and the political speculation, and a much clearer picture emerges. China didn't go to the moon to claim territory. There are no borders there, no property lines to mark. They didn't go to mine resources tomorrow. Large-scale extraction is still years, possibly decades, away from being practical. What China is doing instead is far more strategic and far more permanent. Went to the moon to control the bottlenecks of long-term presence. Power generation, where sunlight is consistent and reliable. Communications infrastructure, signals relay when Earth isn't visible. Logistics systems, how machines, materials, and eventually humans coordinate operations beyond Earth orbit. And energy access, not just what theoretically exists, but what can realistically be reached, processed, and sustained. This is why their program emphasizes infrastructure before astronauts, systems before spectacle, repeatability over speed records. It's also why everything feeds into a much larger vision, the International Lunar Research Station. Permanent modular presence, or independent, designed at least structurally for multinational participation, offering countries pathways to operate on the moon without constructing everything from scratch themselves. Not ownership, influence. Because in space, control doesn't come from planting flags in dirt. It comes from making yourself impossible to work around. The real race was never about who touched down first, about who builds the infrastructure that everyone else depends on. In that race, arriving late with better preparation beats arriving early and leaving. China understood that from the beginning. It's why they're not just visiting the moon. They're becoming the foundation everyone else builds on top of. Moon is back in the game. This time, it's not just a symbolic destination, a springboard for the future, an outpost for longer missions, a power plant, a laboratory beyond the reach of Earth's noise, perhaps a new territory for humanity to occupy. The far side of the moon, which remained invisible to us for billions of years, is now illuminated by technology, ambition, and curiosity. Whether it's the search for helium-3, presence of frozen water, or the perfect silence for science, it become the ultimate testing ground of the new era of space exploration. Whatever is discovered there could change not only the course of science, but the very fate of Earth itself. The future of our civilization may very well be taking shape right now in the most silent and mysterious place in the solar system. Found this interesting? Hit that like button and subscribe so you don't miss future videos. Turn on notifications. Question for the comments. If you could visit one location on the moon, would you choose a sunlit ridge with constant power, or a shadowed crater hiding ancient ice? For watching. See you in the next one.